Most people struggle more on the simplifying ones than the multiplying and dividing, which always shocks me because this is literally just the left-hand side or the right-hand side of the multiplying and dividing. It's less work, not more. Okay? So when it's just a plain old rational like this, or it's multiplying, or it's dividing, we'll follow the exact same steps. Our first step is GCF for difference of squares if possible, right? Or if it's a monomial, like the first one is all monomials, what do we do when they're all monomials? We just put everything in their own brackets. Everything in their own brackets because everything is just multiplied. There's no plus or minus signs, correct? So monomials are done the worst, but they shouldn't be. It's just like people forget how to do them. So monomials have no GCFs or difference of squares because there's no plus or minus signs. So we literally just write everything in its own bracket. So the 4 goes in its own bracket, the x squared goes in its own bracket, the y goes in its own bracket, the 25 goes in its own bracket, the x, and the y squared. Then I say to myself, what are my NPVs? How many brackets do I have in the denominator? I have 3. How many variables? 2. So I have 2 NPVs. It's x and y squared. So they're variables that are just by themselves, right? And variables just by themselves can't equal 0. That's the key for NPVs. And make sure you're showing all the work. So x can't equal 0 and y can't equal 0 because they're just by themselves. But a lot of the time they'll be written like this. X comma y can't equal 0. That's often how they put them together when they're both the same one. Once I state NPVs, then I'm allowed to cancel if things cancel off. So the 4 and the 25, can I take anything out of those? No. Then I have an x squared and an x. So this x can take off itself, which is x to the 1. Then I can take off one of these. So I'm still left with x to the 1 there. This y can cancel off one of these y's, so I'm left with y1 on the bottom. And so I'm left with 4x over 25y. And I could leave them both in separate brackets or no brackets at this point because it's the answer, right? And they're monomials. Brackets just mean they're multiplied. No brackets means they're multiplied. So I can just leave it like that. And then I have x comma y can't equal 0. Now B has a binomial and a monomial. Binomial in the top, meaning it has a plus or minus sign. Monomial in the bottom. So if I actually were to deal with B, I could just go 56V minus 72. The 56V and the 72 are joined together by minus sign. So they're in their own brackets like this. And then we have a 32V on the bottom, which is a monomial. When I have a monomial, I just go put everything in brackets, right? So I get 32 and V. Currently, I can cross nothing off. What could I still do, though? I never did. I can take out an 8 out of the top. I can still take out a GCF, correct? So I can take an 8 out of the numerator. So if I take out an 8, I'm left with 7V minus 9 over, and this 8 can go in its own brackets because it's sitting in front, 32 and V. Now I see there's stuff I can cancel, but before I cancel, I always have to make sure I state NPVs. So I have a 32. That's great. Great number. Nothing to do with NPVs. And then I just have a V by itself. So my NPV is just going to be V can't equal 0. And now I can cancel off if anything is the same. On the top, I have a 7V minus 9. Is there a 7V minus 9 in the denominator? No. So I expect my answer is going to have a 7V minus 9 in the numerator boxed. Because it can't ever go away. Because it needs a twin in the bottom to go away. There is no twin. Right? Then I have a V in the denominator. Can I cross it off with this V that's attached to the 7, that's attached to the negative sign and the 9? No. This V is only going away if on the numerator I had a V or a V squared, a V cubed, V4, V5, V6. If I had those by themselves, that's the only way this V is going away. So it's not going away either. So the only thing I can do is the 8 and the 32. I can take an 8 out of each. 8 divided by 8 is 1. 32 divided by 8 is 4. And so I'm left with 1 times 7V minus 9, so just 7V minus 9 over 4b. Now, some people will say, well, I can take this b off with this b. Can I do that? No. The 7b minus 9 doesn't need brackets, but if you want to put brackets around it so you stop yourself from accidentally crossing off things you can't do, then go for it. Okay? And we have 12 behind with b can't equal 0. Then we're going to look at C, and then you're going to work on some more. So C, I would star C. C is one that gets done wrong just because you have the wrong signs, which makes sense in a second. So I look at C, I have a binomial over a binomial. I hate this board so much. Last class, it was just changing colors. Like I'd have blue, then it would write into red, then it would go to black, then it would go to orange. Like it's just halfway through my X, part of my X would be red, and the other part would be blue. Like it's awesome. So I have a binomial over a binomial. Currently, do those binomials match? Are they twins? No. So I could do nothing if this was it. But I ask myself, can I do any GCFs or difference of squares when it's a binomial? When it's a monomial, I go right to brackets. When it's a binomial, I say, can I take out a GCF or is there a difference of squares in the numerator? What can I do? GCF of a 5x. So I take out a 5x from 5x squared and I'm left with x. Negative 5x divided by 5x is negative 1. Remember when you take it out, it doesn't go 0, it comes 1. The 5 and the x are sitting in front, multiplied, so I can put them in their own brackets if I want to. Now the bottom is 1 minus x, which is hard to compare because it's 1 minus x and the top is x minus 1. So they're not actually in the right order. So for me to compare them so I don't make an oopsie, I will write one of them like the other one. So I've already wrote the top one, so I'm going to leave it there. I'm going to write this one in order of x first, then number. Okay? And I have to remember to take my signs with it. So I'm going to take negative x and write it first because the negative's with the x, and then this is a plus 1, right? So I'm going to go plus 1. When I write them in the same order, it's a little more obvious that they're actually the complete opposite of each other. Do you see that? Remember I told you if you get stuck, most of the time it's a difference of squares. Check for a difference of squares. It's often a difference of squares, right? But also what you need to check for, that's why I told you to start this one, is when you have the exact same twin, basically, but wrong signs, you can make them be the same by taking out a negative 1. So this one I have positive x minus 1. This one I have negative x plus 1. They can't be like partly the same. You can't have like x minus 1 and then x plus 1. Those are totally different, correct? If you want to make them the same, they have to be completely the opposite signs. Every single term in that bracket has to be completely opposite signs. So it's a positive x minus 1. This is a negative x plus 1. So they're completely opposite. So I'm going to leave the top be the same. You could have taken a negative 1 out of the top, but I'm going to take a negative 1 out of the bottom. If you have the same answer, it's totally fine. I'm going to take a negative 1 out, because if they're this exact same but wrong sign, I take a negative 1 out of one of them, not both. If you take a negative 1 out of both, you're undoing it. They're both still going to match different, right? So just one of them. So I take a negative 1 out, and when you take a negative 1 out, it just changes the signs. So negative 1 out of negative x, I'm left with x. Positive 1, take out a negative 1, I'm left with negative 1. Now do they match? Now I'm going to have something to cancel off. We agree? But before I cancel, because I'm excited they match, what should I always do? NPVs. So this one, negative 1 is just a number, no problem. I have x minus 1, can't equal 0. Add the 1 over. X can't equal 1. Bless you. Bless you. So then I have an x minus 1 and an x minus 1 that can cancel. We agree? So I can rewrite this as 5x over negative 1, which is not incorrect, but that won't be the multiple choice answer. How are they going to write it if you have a negative 1 just sitting in the bottom? Yeah, you can move it to the top, right? Technically, you could just multiply this by negative 1 and this by negative 1. So you'd get negative 5x over 1. That's what you're doing when you're just moving it to the top. You're technically multiplying the top and the bottom by negative 1. And then we say x can't equal 1. I'm going to have you work on D, E, F. Now keep in mind, E and F are multiplication, but the only thing that multiplication causes is more MPVs, right? You're going to draw a big thick line in between. You're going to have a full numerator over a full denominator just like we did. But you have to do GCF difference of squares of all numerators and denominators. Catch on E and F is they're all monomials, so you just go to brackets. No GCFs or difference of squares. So try these ones out. Okay, so we have a simplifying, basic simplifying one. It's a binomial over a binomial, so the only thing I can do is GCF or difference of squares. The top I can take out of 4, and then I'm left with x squared minus 9. And the bottom I can take out of 2, and I'm left with x minus 3. The key thing to the x squared minus 9 is it is a difference of squares. So we have to be able to spot those, or we're not going to simplify them. Square root of x squared is x. Square root of 9 is 3. We have a different sign, so it is a difference of squares. We're going to get x at the front of each bracket, 3 at the back of each bracket, and then one of them has to be positive and one of them has to be negative. So we have to spot the difference of squares questions. So on the top here, we're going to get 4 over x plus 3, x minus 3. And then on the bottom, we're going to get 2 over x minus 3. And then I see that I can cancel things off, but I have to stop myself before I cancel, because I have to make sure that I state NPVs. Now these can be in their own bracket. So I have a 2 in a bracket, which doesn't cause me a problem, and then I have an x. So I'm going to have one NPV because there's one bracket with a variable in it. So my NPVs are going to be x minus 3 can't equal 0. Add the 3 over, so I get x can't equal 3. And then I say, okay, I have x minus 3 and x minus 3. They match. They're twins, so they can go away. Is x plus 3 staying for life because there isn't one in the bottom? And then I can take a 2 out. 4 divided by 2 is 2. 2 divided by 2 is 1. So the entire denominator cancels off. Do I have to write a 1 if the denominator is 1? No. Do I have to leave a 1 if the numerator is 1? Yes. So if your entire numerator cancels off, you have to put a 1. If your entire denominator cancels off, you don't. Because, for example, 4 over 1 is just 4. So I don't have to write the 1, correct? But 1 over 4, is that just 4? No. So if your whole numerator cancels off, you have to keep a 1, because that's not true. But if your whole denominator cancels off, you don't have to write the 1. We could just write the 4, right? So if your denominator cancels off, it can go away. So all we're left with here is 2 x plus 3, and then x can't equal 3. So those were just basic simplifying. We're going to do the same here for multiplication. The only catch is, with multiplication, you technically have 2 simplifyings. So you have to simplify twice and then make the whole numerator, whole denominator, right? If we look at E, E is just monomials, correct? And what do I do when I have monomials? Brackets. I bracket everything. So I'm going to go 5 and then y squared over 3 times 9 times x over 10 times y. So how many brackets do I have in the denominator? 3. How many of those brackets have variables? Just 1. One of them has a y, correct? The other one is a 3 and a 10. The 3 and the 10 do nothing. The y is our problem. So when we have a y squared, y cubed, y4, y100, whatever it may be, our MPV is going to be y can't equal 0. So the first step is simplify the tops and bottoms of both sides, correct? Second step is state MPVs. Third step is make a really big, thick line between the two, and now we can cancel off stuff. So I have a y in the bottom over here. It can take off one of these y's, so I'm still left with y to the 1. We agree? The x on the top, is there an x in the denominator, in the bottom? No, so that x is staying. There's nothing to cancel. I have a 5 and a 10, so I can take a 5 out of here, get 1. 10 divided by 5 is 2. And then I can go take a 3 out. 3 divided by 3 is 1. 9 divided by 3 is 3. So I'm going to get 1 times y times 3 times 1 times x. So I'm going to get a 3xy on the top. They don't write it as yx because they always write your variables in alphabetical order. But if you wrote 3yx, you wouldn't be wrong, just so you know. They're always going to write it in alphabetical order. All over 2. And then y can't equal 0. So same thing's going to happen for f. F is just brackets, and the brackets confuse people. Remember, if you have 2 brackets touching, that's just multiplication, correct? So it's just another way of showing multiplication. They're still monomials, so I'm going to write them in brackets. I'm going to get a 9 and an x cubed all over 8 times 32 and a y all over 27 and an x4. Now, first step is to write them all in brackets if it's monomials. Second step is non-permissible values. So I have an 8, a 27, and an x4. The 8 and the 27 cause no problems. The x4, x to the power of 4, my NPV is going to be x can't equal 0. Now that I stated NPVs, I draw a really large, thick line connecting all my numerators to the numerators and all my denominators to the denominators, right? Do I have anything in common? Well, the top I have 3 x's. The bottom I have 4, so it takes away all of them but 1. I have a y in the top, but I don't have a y in the bottom. Nothing can happen. 32 and 8 have 8 in common. So 32 divided by 8 is 4. 8 divided by 8 is 1. 9 and 27 have 3 in common. Or have 9 in common, sorry. 27 divided by 9 is 3. 9 divided by 9 is 1. If you don't simplify the numbers, you could just technically multiply 9 times 32, multiply 8 times 27, and then reduce them at the next step, right? You wouldn't have to do it at this point. And so what are we left with on the top? We're left with 4y, and then on the bottom, we're left with 3x. And I look and I say, yep, that's as simplified as it can go. If it isn't, I just do another step and cancel off more things, right? And then I say x can't equal 0. G, once again, monomials. I'm drilling home the monomials because honestly, they're the easiest thing to do and they're the worst done on tests because people don't know what to do. They want to like GCF for difference of squares and you literally can't. So it's monomial over monomial, so we're literally just going to turn the monomials into brackets. So we're going to get 7 a cubed over 10 b7 times 5 b cubed over 3 a. So I have a 10, a b7, a 3, and an a. So 2 of them have variables. The b7 is just going to be b can't equal 0, and the a is just going to be a can't equal 0. When your variable is just by itself without anything attached, it just can't equal 0. So I'm going to have a and b can't equal 0. Monomials always end up like that. Once I've stated NPVs, I go to a really thick line, all the numerators over all the denominators. Then I say what matches. Well, I have 1a down here, can take off one of these a's, so I'm left with a squared. I have 3 b's here, can take off 3 of these b's, so I'm left with a 4. 5 and 10, I can take a 5 out of both. 5 divided by 5 is 1. 10 divided by 5 is 2. And so on the top, I'm left with 7a squared. And on the bottom, I'm left with 6b4. Then I ask myself, can I cancel anything else off? Can I make it any lower? 7 and a 6, no. A and a b, no. So I'm done. And I just say a, b can't equal 0. So those were all monomials. Monomials are nice because you just go straight to brackets. H has some monomials and some binomials. Do you see that? So technically, if I were to rewrite this one, I would have 3x minus 6 in a bracket. I would have 5 and x in separate brackets because they're monomials. I would have x cubed in its own bracket. And I would have 5x minus 10 in its own bracket. Because they're attached. Can I do anything else, though? The top left, can I do anything to it? What can you do? Yeah, you can take out a GCF of 3, the greatest common factor. So we can take a 3 out, and we're left with x minus 2. And the 3 goes in its own bracket, over 5 and x. X cubed stays x cubed. What can I take out of the denominator, the binomial? 5x minus 10. 5. And then I'm left with x minus 2. And then I have to state my NPVs. So I have a 5 and a 5 do nothing, and then I have an x and an x minus 2. So I have 2 NPVs because 2 of my brackets have variables. So I'm going to have x can't equal 0 for the first one. And then I'm going to have x minus 2 can't equal 0. Add 2. X can't equal 2. So I have 2 non-permissible values. So my first step is monomials go in brackets. Binomials are GCF difference of squares. Second step, NPVs. Third step, full numerator over full denominator. And then see if I can cancel anything off. So, the x minus 2's matched. They can go away. This x can take off one of these x's, so I'm going to end up with an x squared. What about the 3 and the 5 and the 5? Can I do anything? Can I cross these two 5's off? No, they're both in the denominator, so I can't cross them off. They have to just join together and make 25. So I'm going to get 3x squared over 5 times 5, which is 25. And then I say x can't equal 0 or 2. So then we're going to flip over. There are 3 more multiplications. I, J, and K work quickly because I want to go to the divisions. Luckily, I was choosing to not record. I didn't mean to box that one. T can't equal 2. Then I make a full numerator over a full denominator. Now, I can cancel off the t minus 2's, and I can cancel the t off and get a 2 here. What if I don't cancel the numbers? What if I just write them? Sometimes it's hard for people to cancel them off, and I'd say 50-50. I'd say 50% of you find it harder, and 50% of you do not. There is an easy way to just not to bypass that whole crossing off the number system. Just don't. So I can go 5 times 6 because their coefficients is 30, t squared. And then I can go 10 times 4 is 40. And then now I reduce. You don't have to reduce in the step before. You can reduce the coefficients after, right? So you can have your calculator do it for you. You can go 30 divided by 40, math, enter, enter, and it'll reduce it to 3/4. Or you can say, hey, I can take a 10 out. So I get 3 over 4 with the t squared on the top. So if you're someone who is struggling with that canceling, don't. Just don't cancel the coefficients off. Put them together, then cancel. Because sometimes that's easier. So you'll still get the same answer, and then you say t can't equal 0 or 2. Some of you will skip the middle step. Totally fine, as long as you're not doing it wrong. J is y squared minus 16 is a difference of squares. So I'm going to get y plus 4, y minus 4. The bottom, I can take out a 2. So I told you, if you're missing something, it's often a difference of squares. We agree? So you take out a 2, and we're left with y plus 3. Then we do a multiplication dot. The top I can take out a 4, and I'm left with y plus 3. And the bottom I can take out a 2, and I'm left with y minus 4. Then I state NPVs. They're just going to be for the y plus 3 and the y minus 4. So I have y plus 3 can't equal 0. Y minus 4 can't equal 0. This one's going to be y can't equal negative 3. And this one's going to be y can't equal 4. Then I make a common numerator and a common denominator by drawing a really thick, big, long line. The y minus 4's cancel. The y plus 3's cancel. And you could see that the 4 and the 2 and the 2 cancel. If you don't see that, I do not care. Like I said, put the coefficients together, right? Don't overthink the problem. Just get rid of the variables. So now I have 4 and y plus 4. And then 2 times 2 is 4. So if you don't reduce the numbers, it's not a big deal. You can now reduce them, right? I can take a 4 out of the top and the bottom. So this cancels this off, and I'm just left with y plus 4. The denominator went away. I don't need to write it. Y can't equal negative 3 and 4. K is one of the hardest ones I can give you in 30-2. So for K, the top left I can take out a 2, but when you take out the 2, you're left with x squared minus 16, and what is x squared minus 16? It's the difference of squares, right? X plus 4, x minus 4. So I'll do that in a separate step. Here I'm going to get x squared. Here I'm going to take out an x. And then this one I told you it's sometimes easier if you just rearrange it with the x first, right? So it's going to be negative x, you have to take a sign with it, plus 4. Then this becomes a difference of squares, so I get 2 x plus 4, x minus 4. All over x squared. And then this I get x minus 4. And I need an x minus 4. On the bottom I have a negative x plus 4. So it's the complete wrong signs, correct? You see that? How do I fix wrong signs? Take out a negative 1. So if I take a negative 1 out of the denominator, my negative x is going to become a positive x. And my positive 4 is going to become a negative 4. And then they match. So if they're the exact same but wrong sign, take a negative 1 out and it will switch the signs. Then I state my MPVs. I have x can't equal 0 because of the x squared. And I have x minus 4 can't equal 0. X can't equal 4. Then I can draw my full numerator over my full denominator. And cancel stuff off. So these go away. This x takes off one of these. And nothing else cancels. So in the top I'm left with 2 x plus 4, x minus 4. And in the bottom I'm left with negative x. And that negative could move up with the 2, and then this would be a positive x. Doesn't matter. X can't equal 0 or 4. Now, L is a division. I'm going to tell you right now, division is basically multiplication. It's one step away. And when we do rationals, rationals follow fraction rules. So let's just go back to what a fraction would be if you did division. So I'm just going to show it up here. So if I had a quarter divided by a half, what did your teacher tell you to do? Anyone remember? Yeah.
Flip the second fraction.
Yeah. And then multiply. So they called it flip and kiss. Some called it invert and multiply, which you're dividing by. Some said keep, flip, change. Like, it doesn't matter what acronym you used. What matters is the second half flips and it becomes a multiplication, right? So it would be 1/4 times 2 over 1. So do you see we're one step away from literally multiplication? That's all division is. Division of rationals is one step away from multiplication. There's actually no way to divide. You actually just flip it, and now you're multiplying. We do everything like we just did. So division is not harder. There's one catch to it though. You state NPVs of anything that has been in the denominator or will be. So let's look at this first one here with L. They're all monomials. If they're all monomials, I still just put them all in brackets. Nothing has changed. I don't know why I'm doing that. So I'm going to go 9 and x5. And then I have 8 y squared z. Then I have multiplication. And then that second half is going to flip. So everything that's in the denominator moves to the numerator. Everything in the numerator moves to the denominator. So I have 16 y9 z squared. And on the bottom, 3 into x. Am I literally just doing exactly what I did above now? Yeah. Here's the catch. This is the catch, and they'll often ask for NPVs of division. Because NPVs of division have an extra NPV. Because non-permissible values happen when your denominator can't be 0. Denominators, correct? So we have to state the NPVs for this denominator and this denominator, we agree? But with division, we also have to state NPVs for this numerator. Why? Anyone know? Yeah. Because you flip them and now 3x is actually in the denominator, correct? So only with division, not addition, not subtraction, not multiplication, not normal simplifying, only division, do you state it for both the denominators plus the right numerator. Now some people will go as far to do the left numerator, but does the left numerator actually ever make it into the denominator? No. So we don't state it for that one. It's just this one, and this one. And remember, monomials are the easiest NPVs to state, because it's just whatever variables are there, they can't equal 0. So I have a y, a z, an x, a y, and a z. So I basically have x, comma y, comma z, can't equal 0. And then I'm just back to the previous questions. I have a multiplication statement. Draw myself a really long line. So if you can multiply, can you divide? Yep. What's the scary part if you can't multiply? You can't divide, because they're the same thing. You can't simplify either. They all follow the exact same rules, which is nice, because you have the same rules over and over and over. Addition and subtraction do not, and neither does solving. So it's just for these 3 lessons. So we say what's common. Well, I have a y squared and a y9, so I can take off 2 of these, and I'm left with y to the 7. This is an x5 over x. So this x can cross off one of these, so I get x to the 4. And then a z, it can cross off one of these, so I'm left with a z. And then the 8 and the 16 can cancel, the 9 and the 3 can cancel. But what if you're not good at that? Who cares? Put them together. So you can go 9 times 16, 144. X to the 4, y to the 7, z, and then on the bottom you have 8 times 4, which is, or 8 times 3, sorry, which is 24. And then you can just put those in your calculator and reduce them. Like you could put 144 divided by 24 and then math enter, it'll reduce it for you. So you can either go ahead and literally cancel the 3 and the 9 and put a 3 at the top, 16 and 8 put a 2 at the top, and then you're going to get a 6. Or these will reduce. 144 divided by 24 is 6. Right? So you take a 24 out of both. So you can either do it this way, and then it reduces to 6, x4, y7, z. Or you could do it the way we were doing before, cancel it. 8 gets me a 1, 16 gets me a 2, this gets me a 1, this gets me a 3, and I have 6, x4, y7, z. Which one is better? Trick question. The same answer for both? So which one is actually better? Whichever one gets you the right answer. So if you're better off with just putting them together than reducing them, please do that. If you're the person who has to reduce them first to get the right answer, please do that. I need you to do whatever gets you the right answer. Because ultimately in the end they're the same answer. Right? And then behind it we put x, y, z. So tomorrow for homework I'm checking M, N, and O. There's 3 of them. These 3. So they're literally just multiplication. They're one step away from multiplication and they get you an extra NPV, right? That's it. Just these 3.